Hi, this is episode 86 of Crondos. I'm your host, Jordan Hudgens. I'm a Ruby dev and the CTO of the DevCamp platform. Continuing on our series on solid development practices, in this guide, we're going to walk through the Liskov Substitution principle. When it comes to object-oriented development, the Liskov Substitution principle can be slightly confusing, to say the least. And part of the confusion comes from the fact that the principle has more of an effect with statically typed languages such as Java. However, it's still an important concept to understand, so stay tuned, even if you're a developer that focuses on languages like Ruby or Python. I'm going to walk us through a practical example of how this code applies to all object-oriented languages. To be 100% transparent, I struggled through researching this topic, but what helped me understand this was first, talking it through with a software engineer that I respect, a gentleman named Chase Baker, and next, breaking down the definition into small, manageable pieces. With that in mind, let's walk through a dead simple explanation of the concept. The Liskov substitution principle states that a program should have the ability to replace any instance of a parent class with an instance of one of its child classes without negative side effects. If that is about as clear as mud, don't worry. This principle is not for the faint of heart. It helped me tremendously to break the definition apart, so let's give that a shot. We'll start with the fact that we know we're going to be working with replacing instances of classes. Next, we know that we're going to be working with parent and child classes. This tells me that the principle revolves around object-oriented inheritance. Lastly, it sounds like programs have to be able to allow for child class instances to seamlessly replace parent classes. This tells me that we're going to have to focus on the messages that are being sent, along with ensuring that our parent and child classes can't have requirements that would cause conflicts. Still confused? That's fine. This concept took me longer to understand than all of the other solid principles combined, so you're in good company. For our code walkthrough, I created a basic user class in Ruby. Additionally, I built an admin user class that inherits from the parent user class. These classes have attributes for settings and email. In our case study, we decided to make an interesting decision to use the hash data type for our settings in the user class. However, we're using the array data type for our admin user class settings. This seems like an innocuous issue because if we run the program, both classes seem to be working just fine. Our problem may not be evident quite yet. However, watch what happens when we need to build a new feature. Our new feature is a script called signed in today. That's going to run every single day, and it's going to generate a report that lists out which users logged in that day. It combines both regular and admin users into an instance variable called user database. From there, it loops through the settings for all the users to see if the user signed in that day or not. This is a pretty common feature, but let's see what happens when we run this code. Our script works perfectly fine for a user that was created straight from the user class. However, it breaks when it comes to our admin user and gives the error that says no implicit conversion of symbol into integer, which is essentially just a type error. The bug with this program is relatively straightforward. Our signed in today method is looking for settings that are stored as the hash data type. But when it encountered the admin user settings, which are stored with the array data type, it throws an error. So does this example qualify as a Liskov substitution principle violation? Let's look at the definition again. It states that a program should have the ability to replace any instance of a parent class with an instance of one of its child classes without negative side effects. In our example, we attempted to substitute an instance of our child class, our admin user, for its parent class. And by performing this action, it broke the program, which I think qualifies as a negative side effect. Now let's see what we need to do to fix this. You may think that it's as easy as just changing the admin settings call so that we pass it a hash like this. And yes, technically that would work for this one instance. However, that doesn't fix the core problem, and this bug will continue to happen if a developer forgets that settings need to be a hash. So what's a better solution? Personally, I'd attack the root issue and force the programs to only have one option when it comes to saving settings. In this code, I'm importing the OpenStruct library. Next, I remove settings as an attribute of the class and instead create a method called setSettings that can be called and saves the settings into a new OpenStruct data type. Then settings can be called from anywhere in the application for the user class and any child classes it may have, and we can trust the behavior that it's going to generate. With this fix in place, our admin user class instances can replace any instance of the user class and the program will still work properly. I hope that this has been a helpful guide to the Liskov substitution principle and that you can feel more confident with how you can apply this concept in your own work.